Before using the spectrophotometer, it is important to fill each cuvette exactly to the line with your samples in order to get the best absorbance readings.
It is important to scan across all wavelengths at first in order to find the lambda max. Lambda max is the wavelength at which the solution absorbs the most light in the spectrometer. It is at this wavelength we will require the best absorbance readings. When using a spectrometer, it is important to zero the machine. If you do not zero it, then you will probably get a larger absorbance reading, which will mess up your data and not allow you to find the right concentration value.
Before putting a sample in, it is important to clean it with a Kim wipe on both sides, the sides that the light beam is going to shoot through. Close the spectrophotometer and read the absorbance using the machine. It is important to write it down in the lab notebook for future calculations. After taking out the sample, make sure to close the spectrophotometer. Here, Alan demonstrates the second dilution reading. Click on Read, and in the top left corner is your absorbance. At the end of every lab, it is important to clean up.
The Beer-Lambert law is the linear relationship between absorbance and concentration of a solution. The equation is A equals a lowercase a times B times C, where A equals the measured absorbance, lowercase a is a wavelength-dependent absorbability coefficient, B is the path length, and C is the analyte concentration. Absorbance and concentration are directly related. If one increases, then so does the other.
Now that we have all of the absorbance readings of our samples and the molarities that we calculated when making the dilutions, we can now use Beer-Lambert's law to find the concentration of the unknown. Oh boy, do we love spectrophotometry!